APAN. So now they are prime sponsor finally, and then they have a separate thing within the country that they can show whatever they have the new thing to the country, and they also have dinner for you. But that's the thing. This time already passed last night. Usually it's Thursday. Oh no, Wednesday. Eh? Yesterday, Wednesday. I'm just confusing. So this is the fourth day. So it's fourth day of APAN, and then the session still going on. Not much for telemedicine. Usually telemedicine they have Monday morning until Friday evening. Like what the why? Like very intense. But this time, Moriyama Sang said it's like difficult to arrange, and then something happened that the Japanese or they said not coming because of the situation here. So we missed that. And then some session got canceled because the share cannot come. So it's have to be nobody take over. So next time for I think Federation, we will try to find someone if we cannot get him back, something like that. So welcome to the uh, sorry, agriculture working group. So I will have to give you a bit of. My name is Virachai Tanpipat from Hydroinformatics Institute, and now I also helping out the University Network, UniNet as well. So try to look at the how to get them involved more into APAN because they disappear for a few years now, which is not good. So we try to get them back. So the way to get them back, I have to help them. Just the way, because they consider to be NREN, the main call for the Ministry of long name, Ministry of Higher Education, Science, Research and Innovation. They combine the ministry, so now it become from Science and Higher Education to be one. You are sitting in the oldest working group of APAN. It started in 1998, and then keep going along. At the beginning, Ninomiya Sensei is the one, was the one, whatever, did the grammar thing, who founded with the group for APAN. And it has been going on since until now. So this is year number 28 already. So in the past, I think 10 years after Dalian HII get involved and become the chair, switched by the director. And then today we'll add Shalinda. I'll detail at the end during the discussion to be a co-chair more because we have so many co-chair, but nobody helping. We try to find the one that would be able to support us. So that's one thing. And then agriculture working group work closely with disaster mitigation. I think I believe Eric is also co-chair for agriculture. No, okay, but cloud, and then co-chair of the disaster mitigation. So we work closely with disaster mitigation, and then lately, after Dalian, I don't remember what APAN, but perhaps almost 10 years ago, we started the open and sharing data, and we will add the name because people are like, oh, why just open and sharing? We will add the name toward open science because we work closely with those people. So that will be changing in APAN62. For now, just welcome, and I don't know the speaker is here or not. The first speaker, what is first speaker? Is he here? Iman. We still have time for the, what? Introduction 8:45. It's not started session yet. Session started now. I know. But now here said introduction is 8:45. Okay, it's fine. The first speaker, I don't know he's online or not, Professor Abun Noman, from the Bangla, Sheikh Bangla Agriculture University. Are you here? Not in the Zoom. Are you in the room? I don't think so. Uh-huh. Okay. Maybe we have to. Oh, the director is already online? No, she's not there. She's not there. Not yet. She will come later. So before we start, then we have to wait for him a little bit because his talk actually from now, but he's not here. Let's see. The second speaker then, check. The second speaker, Professor Manan Aslam. Are you here? Uh-oh. Nope. Online? No. Okay. The third speaker, I hope she or he is here. MD Shad Fakir, Bali. No, I mean the name is the same. Okay, it's a from the Dennis Science and Technology University, Bangladesh. Are you here? No. Online? Oh, they cannot hear. Okay. Is it that from BD9? Different. Uh-oh. The fourth speaker is Shalinda. So you are here, then maybe you can start and we have more time because the first three speakers not here. So we move Shalinda up. Then you have a lot of time to speak up to you until they show up. So at least you have like 60 minutes now. That's like maybe 40 minutes good enough. You even go further with what you doing in the Sri Lanka regarding agriculture now. Yeah, because three of them not here. So this is the first speaker, and we Dr. Shalinda Benarakama, Department of Crop Science, Faculty of Agriculture, University of Perennial, Kandy, Sri Lanka. He will talk about the seed system, security assessment, and disaster preparedness, building resilient seed system in climate vulnerable region of Sri Lanka, and probably he will introduce a little bit what's going on about the agriculture working group in Sri Lanka. So he has time, so he can continue. The floor is yours.
Okay, very good morning to all of you. Dr. Chai, my friend, and ladies and gentlemen, it's a great honor and a privilege for me to be here today to share one of the big studies that I conducted with together with some of my friends. So as you see here, the title for today for me to start with, it's about the seed system security assessment and disaster preparedness. This is mainly to build resilient seed systems in climate vulnerable regions of Sri Lanka. So I was so happy to undertake this assignment, this work, funded by the USAID and World Vision before Trump stopped USAID work. Luckily, we were able to finish everything. Um, so the team comprised of 4 academic staff members from my own faculty, Faculty of Agriculture, University of Peradeniya, Sri Lanka, and then the 2 other members, one is the Director General of Department of Agriculture, that's Dr. Vikramarachi, the corner, and the director of the Seed and Planting Material Division of the Department of Agriculture. So it was a very nice work that we did. We were so happy about the outcomes, and it went up to a national document because that was the first ever seed system security assessment that has been conducted in Sri Lanka. So, ladies and gentlemen, let me very quickly get into the topic. The background was because we wanted to assess the seed system in Sri Lanka. Mainly, I'm sure you know, particularly in the developing countries, the seed system is very complicated, very complex. It's not just one line. It's not linear. It's always kind of a network, or I must say, it's a cobweb type of a thing. So as you see here, there are commercial seeds, the government seeds, and sometimes you get seeds as a result of relief aids. And at the same time, the farmers have their own stocks. They exchange the oh, you can't see my. That's okay. They exchange the seeds by themselves, and of course, local market is also there for them to get seeds whenever they want, and this keeps on rotating from one source. The seeds go to the other source. Likewise, it's a very complicated thing. So we wanted to assess the seed system security in Sri Lanka because it's a very vulnerable country. I'm sure you know, very recently also because of the Ditwa disaster, that cyclone, we were heavily devastated, damaged by the torrential rains and the landslides. So, of course, this was done well before that, and we wanted to make sure, okay, we have something with us to assess the seed system security. So, when you look at the key dimensions of the seed system security, there are 5 key things like quality, the seed quality, and whether the farmers have the accessibility to seeds, and whether the seeds are available whenever they want, and of course the sustainability and the resilience. So in this study, our main focus was on the quality, accessibility, and availability. And we wanted to see the other side of the coin, that's the seed insecurity. Though we plan to do a seed system security assessment, the other side of the coin is the insecurity. So we wanted to do that as well. We can see the acute seed insecurity and chronic seed insecurity in any seed system. Mostly the acute seed insecurities are because of the sudden disruptions, mostly with the natural disasters or conflicts or economic crises, something like that. And then the chronic seed insecurity is mainly because of the governing policies of a particular country, or the rules and regulations of a particular country. So we wanted to see how Sri Lankan managerial structure supports or disturbs the seed security of farmers. So we did this study with the understanding what is the importance of having a seed system security assessment in Sri Lanka, because there were many reasons. For example, Sri Lanka is prone to floods, droughts, landslides, and cyclones, as we experienced very recently as well. And seed system security assessments, definitely they help assess resilience, identify vulnerabilities, and create contingency plans. So likewise, there are many reasons why we wanted to do this. And most importantly, this was the first ever seed system security assessment conducted in Sri Lanka. When we were trying to find information about the seed system security assessment, we found one has been done in Bangladesh, one has been done in India. So there are many studies we found, but fortunately, unfortunately, this is the first ever seed system security assessment. So we were very happy about this task. So the study was conducted to assess the seed supply and to investigate stakeholder access and to analyze the varietal suitability to different regions, and of course to evaluate the seed quality what the farmers have, and to enhance system resilience among the farming community. So the study was conducted like this. We have selected 4 districts. of course, 5 locations, but covering only 4 districts where the agriculture is being taken place very commonly in the country. And the World Vision, this institute, they recommended us to pick these locations. With their support only, we picked these locations. And one very interesting thing is, um, even though the livelihood of people in these areas was mainly agriculture, the economic status of people was at a very, very low level. So basically the rural farming community. And we collected data by many sources. We did the desk review, we did the consultation and opinion surveys. And our key strategy was the field survey or the farmer survey. And then we did semi-structured interviews, focus group discussions, joint observation visits. So we tried to triangulate all the data to see whether these information are accurate and can be validated. It was a kind of a big task because we had to complete all these activities within 4 months. That was the timeline given to us. And we somehow we were able to survey 1,329 farmers, farm families. Of course, some of the questionnaire surveys could not take because of many reasons, but finally there were 1,277 taken for analysis. Uh, to do these surveys, we had to train enumerators. So we did this enumerator training by ourselves, going to all these districts physically and doing training by ourselves. You can see, yeah, our team is there training the enumerators. So we took 41 enumerators for the study to cover all these 1,200 odd, 1,300 odd farming communities, farm families. And field observations were done by our team. We went to almost all the places and many farmers, but not to all the farmers because practically it's not, it's, I must say, impossible to visit all 1,300 farmers by ourselves. The key findings, first thing that we did was we tried to identify the strengths, weaknesses, opportunities, and threats in the seed sector in Sri Lanka. So very simply, the SWOT analysis was done. Our main focus was on the weaknesses and the threats. So as you see here, so many weaknesses have been identified, so many threats have been identified. These were there even on books, but practically when we see the outcomes of the study, yeah, we saw these things are in line with our findings. And we wanted to see how the seed system or the seed industry operates in Sri Lanka. Some of the evidence from the desk review. And very interestingly, I'm sure this is the situation in many developing countries in the region. Our market size is not that big, but still it's growing. That's a very positive sign. There are many seed business companies. They are doing really well, exceptionally well, I must say. They are supporting even the universities in many different activities. So the market is growing there, and we expect the market to be grown by 3% or 3.24% by 2029. And another important thing is our formal seed sector is about 20%, 15 to 20%. So the rest of the things, rest of the components are just the informal sector. So this is also sometimes it can be considered as an interesting thing, but just because it's the informal sector, a lot of hiccups are there always. And we we rely on a lot of imports, for example, hybrid seeds. Number one seed type that we import is maize, and followed by bean, carrots, and exotic vegetables, we say in Sri Lanka. So every year we depend a lot of imports. So the seed, particularly the private sector companies, they do these imports. And our number one trading partner for imports is Thailand. It's almost like 48%. We heavily rely on them. Yeah, so we spend a lot of money only to Thailand. We spend about 5.3 million USD per year, right? So Yeah, these were some of the things that we found during our desk review. And then when it comes to the farmer survey, uh, first we tried to see how the demographic information are. So still very commonly the male dominance is there in farming communities in Sri Lanka yet. And the percentages differed depending on the location. So these abbreviations are for 4 different districts that we did the survey on. And the age cohorts, and still we see elderly population or elderly group is in the agriculture sector. Unfortunately, we don't see so much of new people are coming into agriculture in Sri Lanka. But this is mostly in the rural sector, but now we see, especially with the introductions of greenhouses, IoTs and everything, some young generation, the new generation is on board with a new agriculture, modern agriculture. So farm sizes, we evaluated all these, and then we evaluated what type of, we wanted to see what type of crops they grow. And as you see here, depending on the region, the crop type, the dominant crop type is different. For example, in one district, beans is the #1 crop that they grow. But in some other regions, paddy was dominating together with the groundnut. So likewise, region-specific crops were there. And we wanted to see what they grow this season and what they are planning to grow in the next season as well, because very clear 2 agriculture seasons are there in Sri Lanka. Very clear, 2 agriculture seasons. So farmers usually change their crop and the cropping patterns depending on the agriculture seasons. So we want to see what kind of challenges or the disasters and challenges and or the disasters that they face, and whether they are prepared for these disasters. So the major challenges faced by the farmers in accessing seeds. So as you see here, it's mostly the cost of seeds, particularly the hybrid seeds. They are kind of expensive because we almost depend on the imports. So usually hybrid seeds are expensive, quite expensive. So that was the #1 challenge that the farmers had. And then we want to see whether the farmers have experienced any disasters that damaged their crops. So majority of the farmers in all 4 districts, they said yes, they have experienced the disasters at least once. We asked actually whether they have experienced during the last 5 years. So as you see here, 82%, 95%, 65% of the farmers in 3 regions, they said yes. Only in 1 region, just half of the farmers said yes. So something is there. Very interesting findings, actually. And we wanted to see what kind of disasters that they were talking about. Most of the farmers in regions like in this district, Kilinochchi, it's 62% of the farmers say it's about floods. And in 2 districts, they said droughts. And in 1 district, it's the #1 disaster is monkeys. Nothing else. No floods, no droughts, but the monkeys. This has become a serious problem in agriculture in Sri Lanka, particularly in the wet zone. Because still we do not have a solution for this problem. Surely one of the best research topics for future. What can we do with this? Because by the law, you cannot kill them. So they are almost everywhere. So some of the recommendations based on our findings. So we came up with a policy implications or recommendation guideline document to the government. How we can strengthen the seed system security or assure the seed system security in Sri Lanka. Some of the guidelines or the recommendations are given here. #1 being promoting the private sector participation with the support of the government. For example, encouraging private seed companies to come into the picture more and more, because still it's a kind of state dominant seed release is there. For example, it's not that easy for a private sector company or even to a university to release a new variety to the market. Everything has to go through the government varietal adaptability trial procedures or release procedure. And the kind of, yeah, it's challenging, especially for the private sector companies. And then the market development, because currently we don't have a very good market information system, and we don't have promising uh, seed enterprise promotion run by the government. So we have to do these kind of things if we want to develop the seed industry. And always good to establish a robust seed quality control system. This is one of the key findings in our study, because we wanted to see, we collected seeds from all these 4 districts, from the seed vendors, and we saw, as you see here, this graph shows um, different crops on the top, right? And different colors are there for different crops, as you see here. And on the x-axis, we say A, J, I, B, C, or whatever the notation is for the companies, right? We don't expose the names of the companies, but just to show, okay, these are the companies. There are many people who put forward their seeds to the market, and we checked, okay, what is the germination percentage that they have mentioned in the seed label? And then we did the germination study by ourselves. We purchased the seeds and we did the germination trials by ourselves, and look at the problem. Very few companies promised the same seed germination percentage as they have mentioned on the label. But many seed companies failed to keep that promise. So this is one of the biggest challenges we have in Sri Lanka, because this is there because currently, because by the law, it's not that easy to catch these people and punish. Still, the law is not that strong. So we publish actually this article. There were many things that come under this, but we published this article, and we had to present this to the government. And now they are making rules and regulations to control these kind of arbitrary or random seed suppliers to the market. And another recommendation that we gave was to ensure sustainability and resilience. For example, whether the farmers can go into climate smart agriculture, mainly using resilient seed varieties or using sustainable farming practices, or whether the government can support them by giving some credit facilities or insurance schemes. I'm sure you know, not that easy to give insurance schemes for agriculture, especially in the developing countries. But in many countries, these agriculture insurance schemes are there. So we checked whether the farmers are aware about the new seed varieties. Unfortunately, most of the farmers in all 4 districts said, no, we don't know about these new varieties. Not many people knew. Very few percentages, as you can see here. Yes means they know, no means they don't know about. They said, no, we don't adopt, or we never use new varieties. Always we are using what we have used in the last season. And then we wanted to see the source of new varieties. Those who say yes, we want to see, okay, what are the sources of new varieties the farmers have received on for the last 5 years. As again, interestingly, you see the orange bar shows it's the local market. So whatever the seeds available in their local market, whenever they go to the seed boutique, whatever the vendor says, they purchase. This is new, okay, give me that. But so much of problems. And then we wanted to see whether the farmers have received any kind of seed aids during the last 5 years. Not that we are promoting seed aids, but we wanted to see whether the farmers have received. Once again, majority of the farmers said, no, we did not receive any support in terms of, or in the form of seed aids. So likewise, there are many things. So this is why we recommend to go for some supporting systems to poor farmers. Another one we propose, we recommend to go for a supporting of community-based seed system, because we saw most of the farmers, they get together, they share their information, they talk to each other, and they get the varieties or the new seeds by their friends. So why can't we do this officially? Why cannot we make it very legal and with the government's assistance or the support? So we recommend these kind of things, and we check the origin of seeds, and the gray bars are dominating. You can see here, the gray bars are once again local seeds. Even though the Department of Agriculture is also giving seeds, there are many imported seeds. Still, farmers prefer local seeds, locally available seeds. So this is the reason why we think of recommending. We recommended actually to go for these CBSSs. Another one is enhancing policy and regulatory framework. I'm sure you saw how bad the seeds were, uh, the available seeds for farmers. So going for enhancing policy support and strengthening regulatory mechanisms. Another thing that we saw was particularly we talked to the seed producers in Sri Lanka. There are seed producers for not for all the crops, but for some of the crops there are seed producers. So we did some surveys with them as well. We had focus group discussions with them, and we found the infrastructure facilities are not sufficient for them. That hinders their production. So seed production and processing facilities must be there for them. Even the storage and distribution facilities should be there. So we had very nice time with them. We trained them, we talked to them, we had several sessions for them. Um, for example, the whole group is not just the growers, but the seed producers. So we got their feedback. So we included all these into our report. And next one is the monitoring and evaluation. Very difficult to do this, but we have to do this. For example, seed system security assessments, at least every 5 years, the government should do this. Of course, with the support of somebody, but it should be mandatory for a country like us to make sure sufficient seeds are there at the right time, at the right quality. And feedback mechanisms, for example, some of the farmers said, most of the farmers said, we have many problems with the seeds, but there is no place for us to complain. What can we do with that? It was really heartbreaking to see, because they were telling us all the problems, but even for us, we could not give good answers. But we connected them with the Department of Agriculture. Even Department of Agriculture was surprised to see these kind of problems. And finally, capacity building and training. We saw this is one of the most important areas. Some of the farmers have never undergone any training in their whole life. They just do with the experience. So training programs for farmers and even institutional capacity, particularly the extension services, because farmers said extension officers are there, but this is not to insult anybody, but farmers said extension officers know nothing compared to them. So this is also another area that we have to focus on. And the training received by farmers, they said, almost all said, no, we have never received a training. And we tried to identify the training needs. So many training needs were there on board. For example, seed production techniques, quality assurance mechanisms, seed storage and handling, because we saw some of the farmers do not know how to keep the seeds. Some of the farmers said, okay, we are using the seeds that we purchased last season. Even in this season, we are using those seeds, but they just keep the seeds wherever they want. They find something, some place, and they don't consider about the moisture. They don't consider about the temperature, the light. They just keep the seeds wherever they want. So we saw these kind of things as really burning training needs. And sustainable agriculture practices, climate smart agriculture, and business and marketing skills, especially those who produce seeds in Sri Lanka, they did not know how to market their seeds. So some of the things like this, especially now everything is there on the mobile phones, but in these rural villages, the farmers, though they have the smartphone, of course they have the smartphone, but they are not conversant and confident in using this. So so much of training needs have been identified, and we started doing some of the training programs as well. as a result of this, because still the World Vision is very closely working with us, and they asked us to develop some training modules. We started doing some other things. And what we saw at the end was it's all about the knowledge and the intelligence. Some of the farmers have the knowledge, but not the intelligence. So this is a very crucial thing to for a country like Sri Lanka, because we believe we have educated people, but I'm kind of always questioning about the intelligence level of such educated people. And as a summary, um, we try to see the prevalence of seed insecurity. One district, the Kandy district, where I'm coming from, is very vulnerable to acute seed insecurity. Floods, droughts, wildlife issues. So the number of arrows indicate how severe the seed system insecurity is. So this is related to acute seed insecurity. And Kilinochchi, yes, the second most vulnerable district among 4 districts tested, and Kurunegala, Nuwara, the other 2 districts, they are also vulnerable, but not that much, even though many farmers said yes, but it's not that vulnerable to acute seed insecurity, but still they are vulnerable. But the chronic seed insecurity, common to all 4 districts, same problems, same intensities, same levels. So as a result, we suggested the government or the policymakers in our report how to implement these recommendations. So we tried to develop, separate into short term, medium term, and long term like things. So immediately we were suggesting to develop these community-based seed systems and capacity building and training, which we have already started, and long way to go for us. So with that, we have come to the end of the presentation. Thank you very much for listening. Yeah, thank you.
Thank you.
Morning, everyone. I'm Aiko Yamamoto from Muffin. Today, I will introduce Muffin update. And today's topic is shown here. And first, I talk about our services. We mainly operate for systems as shown here. And Math Research Network and Muffin is high-speed network connecting about 60 agriculture research institutes, including branch centers in Japan. And network service system, NSS, provide information sharing services such as mail system and file sharing system for math research institutes. In network railway system, NRS provides integrated agricultural database services and library services. In scientific computing system, SCS provides a supercomputer system related according to applications for scientific computing and agricultural database. And, this slide is the picture of Muffin network. And Muffin is a part of the Ministry of Agriculture, Forestry and Fisheries, MAF. We operate based on ACOA as our basic principle. ACOA means anytime, anywhere. And we provide a collaborative research environment. We are based on Tsukuba City, about 50 kilometers northeast of Tokyo. Tsukuba City is generally regarded as a science city, and most of the headquarters of National Agriculture Research Institutes are in the city. And Muffin is a high-speed and safe network that connects about 60 access points of the following 6 research organizations, including branches. Internet connection is 20 gigabps. Muffin is provided around Tsukuba, allowing users to proceed smoothly with their research by using our services. It is also connected to SciNet and APAN, which contribute to national and international research activities. We are now undergoing our system updates. The next systems will start in March 2026. In this presentation, we will provide an overview of these system updates. Our systems are designed to deliver infrastructure, data foundations, platforms that make agriculture research more efficient and accessible. The upcoming update focuses primarily on strengthening these core elements. We will explain the key points of updating each system on the following slide. This slide shows the overview of Muffin update. We will upgrade the internet concern from 20 gigabps to 100 gigabps by the end of March. And we also replace network switches.
Excuse me, Aiko-san, do you hear me?
Yes.
Okay, many speaker, I would like to inform that the host at the Bangladesh now is they have some problem about the electricity, so they all have disconnect now, and they just want us to just stop presentation now, just around 10 minutes, and they will come back. So then we can restart again.
Okay, I will
okay?
stop.
Yes.
Stop. Okay.
Yes.
Stop.
And if anything okay, I will announce again.
Okay, I'm sorry.
Sorry about the inconvenience now.
Okay.
Hello, how are you, Itiporn?
Hello, we are from the meeting room.
Yes,
Still-
we have problem with the electricity here, the whole floor,
Yeah, the whole floor. So
on and off.
maybe
Maybe
within
a few
5
minutes.
minutes. Yeah, a few minutes.
Okay, I already told Aiko-san to just stop the presentation and we will continue around 10 minutes, right? Maybe?
Don't know the
Okay.
electricity. You don't know.
Okay, so if your sites are ready, maybe we can continue.
Not yet, I think. They just
Just
on and
waiting for
off.
your,
Okay.
okay.
If the internet comes, and then we can.
No internet.
Still no internet in the meeting room yet.
I
Okay.
think probably the whole floor.
Yeah.
Okay,ค่ะ
Yeah, we can resume. Aiko-san, are you still there? Would you share your slide again, please?
Is it fixed? Okay.
Yeah, not yet. Just share again.
Okay.
You can restart. Sorry for inconvenience. It's just never happened before. Somebody here probably swear to the God that I'm blah, 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 blah. And then walking in, oh, that's why it's happened. So please, the floor is yours.
Shall I start from the beginning?
Yeah, please start from beginning.
Okay. So now I'm start from the first. And I'm Aiko Yamamoto from Muffin, and I introduce about Muffin update. And today's topic is shown here. And first, I talk about our services. We mainly operate for systems as shown here. A MAF research network, and Muffin is high-speed network connecting about 60 agricultural research institutes, including branch centers in Japan. A network service system, NSS, provide information sharing services such as mail system and file sharing system for MAF research institutes. A network library system, NLS, provides integrated agricultural database services and library services. And scientific computing system, SCS, provides supercomputer systems, related applications for scientific computing and agricultural database. This slide is a picture of Muffin network. Muffin is a part of the Ministry of Agriculture, Forestry, and Fisheries, MAF. We operate based on ACORE, our basic principle. ACORE means anytime, anywhere. We provide a collaborative research environment. We are based in Tsukuba City, about 50 kilometers northeast of Tokyo. Tsukuba City is generally regarded as a science city, and most of the headquarters of National Agriculture Research Institutes are in this city. Muffin is a high-speed and safe network that connects to about 60 access points of the following 6 research organizations, including branches. Internet connection is 20 gigabps. Muffin is provided around Tsukuba, allowing users to proceed smoothly with their research by using our services. It is also connected to SciNet at APAN, which contribute to national and international research activities. We are now undergoing our system updates. The next generation systems will start in March 2026. In this presentation, we will provide an overview of these system updates. Our systems are designed to deliver infrastructure, data foundations, and platforms that make agriculture research more efficient and accessible. The upcoming update focuses primarily on strengthening these core elements. We'll explain the key points of updating each system on the following slides. Sorry, I tried between. Sorry, this slide shows the overviews of Muffin update. We will upgrade the internet concern from 20 gigabps to 100 gigabps the end of the March. We also replace network switches at all Muffin sites. We have established some connection points with overseas endpoints to enhance the convenience of international agriculture research. Furthermore, the following points are noteworthy. We have implemented UTM solutions for math research institutes, such as narrow, geocast, FRA and FFPRI. These points will be explained in detail in the following slides. This slide shows an overview of the new Muffin Research Education Network connectivity. As I mentioned earlier, we will upgrade our internet connection from 20 Gbps to 100 Gbps. A connection to Fuji XP, which started operation in July 2025, as well as graded by Shinji APAN JP, are now provided through the Muffin APAN router. Previously, we established an international link with ASTI in the Philippines. This link is used not only for network connectivity to IRI, the International Rice Research Institute, but also for transmitting Himawari meteorological satellite data to the Philippines. With this Muffin upgrade, and as a part of our efforts to promote international research collaboration with NRENs, we have added a new connection from the Muffin APAN router to NordNet. This enhancement enables high-speed network connectivity for joint research with the Natural Resources Institute Finland and Wageningen universities in the Netherlands. We are also planning a connection to Thailand. This will support collaborative research between Japan and Thailand, particularly in plant pest and disease control using smart agriculture technologies, as well as animal disease prevention by providing reliable network infrastructure. And so, in this time, why we have decided to install UTMs for math research institutes. First, I would like to introduce about the Muffin's background of organizational IT infrastructure development. Muffin was originally established to support research activities conducted by what is now a National Research and Development Agency, which was a government research institution at the time. Today, it provides integrated information system for functions for shared use, including SCS, NSS, NRS, Muffin, and related systems with a focus on unified information security. According to the initiative titled Efforts to Strengthen the Functions of National Research and Development Agencies, the Japanese government has stated its intention to work in collaboration with the National Research and Development Agency Council to examine necessary measures. This includes considering both hardware and software support as needed. Among the identified challenges, security funding for enhanced information system security measures, such as the implementation of and operation of EDR, web filtering, monitoring of large-scale data downloads, and access log tracking is explicitly mentioned. In response, the planned security enhancement for national research and development agencies will be implemented as a unified system, including spare components to leverage economies of scale and reduce costs. By applying standardized initial configuration and sharing operation procedures to Muffin Research Institutes, a consistent level of security can be ensured from the outset. Given that some agencies under the ministries have already explained security incidents, our ministry, being capable of early system deployment, took the lead in establishing the initial security infrastructure. This will provide immediate protection while supporting a gradual translation toward a model in which each agency independently maintains its own security posture. This slide shows the roadmap for strengthening security in national research and development agencies and math research institutes. Our UTM has the 4-year of hardware support duration from 2025 to 2028. In this term, we will switch the security policy from mapping control policy to each organization-driven policy. This change enables the creation of networks tailored the research teams and security policies of each math research institutes, thereby providing a flexible research network environment that does not hinder the research activities. At the same time, during the warranty period, we will also share knowledge of security technology with each organization, contributing to the enhancement of the skill of the staff engaged in security-related work at these institutes. After the warranty period, each math research institute's organization will introduce the new UTM by themselves. And this slide shows the overview of NSS and NRS updates. The next of NSS will use the function of Microsoft 365. Services that are already provided by Microsoft 365 and can be replaced have been discontinued in the new system, and services indispensable for research activities, such as mailing list, file sharing, and VPN, will continue to be provided because it is necessary for researchers to continue their research. Although the integration with NSS will be handled via Enter ID, eliminating the need to apply for accounts through the headquarters of each agriculture research organization. So this change streamlines the accounts application process, improving overall efficiency. NRS will translate its system infrastructure from on-premises to a cloud environment to achieve stable operation. Furthermore, this system will continue to provide data platforms and research materials which research activities more smoothly. I will explain the details in the following slides. Agropedia is the integrated portal website for OPAC bibliographic and research information. It is written entirely in Japanese, but it includes databases that are widely accessible. The foreign services within Agropedia are made available for everyone to use. JASI, AgroRep, database for MAP-certified agriculture forestry varieties, and historical farming tool database. From the next slide, I will explain the characteristics of each database. And JASI contains bibliographic information from approximately 500 academic journals related for agriculture, forestry, and fisheries published annually in Japan. AgWG includes full text context from each research reports of experimental and research institutions, reports from public testing and research organizations, university research buildings, and academic society journals for which publication permission has been obtained. A database of MAP-certified agriculture forestry publishes information on agriculture forestry certified varieties, which are varieties developed through commissions by the MAP to national research and development agencies, prefecture research institutions, private organizations, and universities, and recognized for their superior characteristics. The example shown in the image is a search for Kita Akari, a potato variety. When you perform the such, certified potato varieties related to Kitakari are displayed. You can also check by the year of certification. The diagram in the lower right shows the access ranking of certified vegetable and fruit varieties. And the image on this slide shows an example of detailed search for Kitakari. It allows you to view a list of information such as with registration number, certification date, former lineage name, and descendant lines, and the place of development. In addition, the key characteristics are described, such as early maturity with high yield, good taste, and disease resistance. Although it tends to fall apart when boiled, it does not darken after cooking, making it suitable for soup and salads. Furthermore, detailed descriptions include a comparison with other varieties regarding planting density, flower color, breeding process, and disease traits to watch out for. Characteristics such as appearance, color, and texture are also provided. Additionally, lineage diagrams and summary charts of growth characteristics, disease resistance, and variety traits can be viewed in the PDF format. Historical farming tool database allows users to search and view images of farming tools that were used in rural areas by name or by the type of work they are used for. For example, this case shows a search for hoe based on a potato. There are various types of hoes, so you can also look up similar tools with comparable shapes. The image on the far right shows a hoe specialized for digging sweet potatoes, commonly used in between 1935 and 1955. You can check historical details such as its size, weight, and the regions of Japan where it was used. This slide is the overview of SES supercomputer updates. While maintaining the current hardware configuration as foundation, we have significantly enhanced performance per node as storage performance. Although the number of nodes has decreased compared to the previous system, performance per node have improved by approximately 3.2 times. This configuration enables handling computations requiring large memory capacities, such as genome analysis, molecular chemistry calculation, and weather forecasting, as well as computations involving large-scale datasets. Furthermore, in previous systems, data read-write speed, I/O performance, could sometimes become a bottleneck alongside CPU and memory. Thereby, by enhancing CPU, memory, and short storage performance, and connecting nodes via a high-speed 400 Gbps network, highly efficient computation is enabled. This is expected to increase computational processing speed by up to approximately 4.6 times. Previously, using supercomputers required knowledge that could be challenging for convenience, such as operating via Linux commands and configuring the public key necessary for connecting to the supercomputer environment. Therefore, starting with the next generation system, the introduction of Open On Demand will enable users to easily access the supercomputer environment, submit jobs, and perform file operations via a web browser interface. This concludes the introduction of Muffin updates. So, thank you for.
Okay, good morning, everyone. Today, my presentation is about the rural hybridization for water resilience agriculture. This is a case study from Ban Saladin Community in Nakhon Pathom province, Thailand. So the outline of my presentation separate to 4 parts. The case study, introduction, rural hybridization concept, the practice and application and achievement. First of all, I want to introduce about the case study. Ban Saladin is in Nakhon Pathom province, located on the west side of the Bangkok, Thailand. Even though it is near the capital city, but the land use rule help keep it as an agricultural area. Most people grow rice, followed by fruit, vegetable, and flower. They mainly use water from the canal system. The Mahasawat Canal is the main canal. It passes the community and connect the many smaller canal. Even though the water flow through the area, however, the community has faces water problem for more than 30 years. There are 4 main issues: flood, drought, breakage, and the wastewater. And there is also one more big problem: the water hyacinth. As you can see in this photo from 1995, the water hyacinth has spread across the main canal and its branches. This made the boat transportation impossible, reduce the water quality, and create serious difficulty for farmers who need to pump the water for agriculture. So at the Hydroinformatics Institute, or HAI, we are research institute, and one of the main mission is to promote the science and technology for community people to use in the water management. We work with Ban Saladin in using the real facts support by science and technology to solve their water problems. Together with the community, we designed the rural hybridization concept. This concept has 4 pillars. The first one, hybrid knowledge. That means combine the local experience with data and technology like maps, field survey technology, and telemetry system to understand the problems and make the better decision. The next one, the hybrid governance, is share water co-management between the community, local government, and the education agency. So the gas operation and the water allocation fit the local needs and reduce the conflict in the community. The hybrid infrastructure means using physical and non-physical structure for management by improve the canal structure and also improve the operation and maintenance using local knowledge and system thinking. And the last one, hybrid economy, that means turns the problem like water hyacinth into the product and income, and use a part of income for the community fund to support the long-term maintenance. For the hybrid knowledge, normally people already know where the water comes from and where it goes. But when we teach them to explain it on the map, it can expand their perspective. And when combined with the field survey technology, they also know the current condition of the system. This data set can be integrated with the to produce the water diagram and water source information for the system analysis. This is the water diagram synthesized by the community from collected information. It is used as a tool for system planning and diagnosis, helping identify the problem in the water delivery and drainage system. And about the hybrid governance, Ban Saladin is in a very strict irrigation area because the water management must not harm the Bangkok. So the irrigation project has strict rules for the gate operation. The community cannot ask to open or close the gate without the strong evidence. So HAI and community, we install the telemetry station to monitor the water level and the rainfall. With this data, we can design action that support both irrigation goals and community needs. For example, to open the gates to move the water hyacinth to the manageable point, or the pumping water to lower the canal level to support the dredging and reduce the flooding. Beyond the irrigation project, the community also used the information system to strengthen collaboration with the other organizations, such as Uttakapat Foundation, the Royal Thai Army, and Mahasawat Sub-District Administration Organization to rehabilitate the canal structure, accelerate the drainage, and reduce the flood impacts. For the wastewater, the main idea is to reduce the household waste going into the canal. A simple tool is the grid trap, which catch the oil and fat before the water goes to the canal. But the grid trap sold in the markets are very expensive. It's about more than 3 times of the daily minimum wage. So people say that no, they don't want to pay for it, and its design is not also convenient for use and install in their kitchen. So we train community to learn how the grid trap work and made a cheaper version using the local material like a can and plastic buckets. And they redesign many things to make it appropriate for community people use. The result, the new version costs about 60% of daily minimum wage. And people can also build it by themselves and learn how to operate and maintain it. And finally, they are willing to use it. The community also built the water aerator system using the renewable energy. It was adapted from the aerator used in the shrimp ponds, then redesigned for local installation and the better performance. The water quality test confirmed that it worked well and improved the water quality. For the drought and brackish water, the community created a model farm plot in water with the water recirculation. It store the water and reuse it inside the plot. So it depends less on outside water. Then they increase the value of water by raising the fish and doing the free chemical farming. It keep water clean. And the result, the fish income is about 3 times higher than rice in 1 year. And free chemical rice can also be processed into the rice crush. It's very famous community products that increase the value up to about 46 times. And about hybrid economy, the water hyacinth is a very big problem. The community tried to compost before, but it's not work in terms of economy. So they study their own context and found that farmer needs a lot of planting soil, and they usually buy it from outside. The community then processes water hyacinth and mix it with the other ingredient to make the water hyacinth planting soil. After that, we send this soil for laboratory testing, and the result shows that high nitrogen and potassium. That means it's good for growing vegetable and fruit. This leads to very high demand from the farmers, and they often result in shortage for water hyacinth for the soil production. Then they also increase the participation by buying the dry water hyacinth from the community people. And to make it sustainable, the part of income from water hyacinth products goes to community funds for canal and environment maintenance. The rest of ingredient, labor, and return to buying the water hyacinth from the household. As a result, the community reduced the water hyacinth by more than 22 tons of dry waste of water hyacinth, and share more than $20,000 of income within the community. Also, the fund is also used to develop and maintain the tools for canal maintenance. For example, the community developed the water hyacinth clearing machine and used the fund resource for operation and maintenance. So this is a comparison between before and after working with HII. The left-hand side is from 2012, and on the other hand is from 2025 on the right-hand side. Overall, the community could address more than 30 years of flood, drought, wastewater, and brackish water problems at the sub-district level, and increase the water security both of quantity and quality, which are suitable for agriculture. And the model expanded to 4 nearby villages in Mahasawat sub-district, benefiting more than 4,000 households. And the next step, we try to expand to nearby district around the Saradin community and nearby the Bangkok.